Okay, it's 4:30, so we're going to get started. Good afternoon, everyone, and welcome to this afternoon's e-learning session. My name is Helen Chen, and I will be your moderator this afternoon, along with Joe Packham and Mark, who I'm sure will be joining us shortly. For the next 30 minutes, we'll be reviewing Lesson 26.1 from Introduction to Algebra Program. And in this lesson, we'll be using the cups and markers model to solve equations. We are presenting a series of 3 live sessions this afternoon. In case you've missed the first 2, they've been recorded, so you can access the archive sessions at your convenience. All you have to do is go to the e-learning page on our website using the link that Joe emailed you and click on the Watch Session button of the session that you want to access. If you are watching this as a pre-recorded session and need to contact us for any assistance, feel free to email one of us and we'll be happy to answer your questions. And we'll put up our contact information again at the end of this session. Okay. I'm doing things a little bit different in this one. Usually I go over the warm-up page before I go over the goals for the lesson, but I'm actually going to hold off on the on going over the warm-up, and there's a reason for that, because I want the warm-up to kind of stay fresh in our heads right before we go into solving equations. Okay, so here are the goals for Lesson 26.1, which is actually called Solving Equations 2. Okay, the first lesson on solving equations with cups and markers was in week 11, I believe, of Introduction to Algebra. And the difference between this one and the first lesson is that in this lesson, in this particular one, 26.1, we introduced negative coefficients. Okay, in both lessons, we use integer coefficients because we're working with a model, but in the later lesson, students will move away from cups and markers and solve more abstract equations that actually have rational number coefficients. Okay, so just know that that is coming in the horizon. Okay. I'd like to briefly point out that there's a difference between the cups and markers model in the Introduction to Algebra program and this session, and it's really simply because I couldn't make the same symbols on the whiteboard. So here we're going to use colors to distinguish between the positive and the negative unit markers, and due to limitations with Illuminate, we're going to use the right side up U and an upside down U to represent our X and minus X. And so this might be a good opportunity to talk about the this teaching tip here on Sloppy Language Alert. This is in week 26, PP6. You'll note how we say minus X instead of negative X, because by saying negative X, we may improperly imply to the students that it represents a negative number. So we try to stay away from negative X, and we say instead minus X. Okay. There's also a strategy for special learners on your planning information page about making simpler drawings to represent cups and markers. So I'm just going to read it real quick here. It says that the trapezoid is used to represent a cup because that's similar shape to a cup, right? But it's sometimes it's difficult and they can get sloppy or it's time consuming or whatever. And so we try to suggest different alternatives to drawing the little cups. You can draw a triangle like this, or just plain, a little square. And then to represent the minus cup, you can draw the triangle facing the other direction, or a black square. Okay, just some of the other alternatives to drawing representations of cups and markers. Okay. Okay. Moving on to the next page. Okay, take a look at these 5 equations. What I'd like you to do is to rank these equations in the order that you think are likely to appear in a traditional math curriculum, okay? And type the order that you rank them in the chat box, okay? So go ahead and take a look at them and then type your answers in the chat box. Okay, so Mark and Joe ranked them the same way. Looks like Pat did it the same way too. And Connie just switched the order of the first and the second one. Okay, let me just tell you a little bit about these five problems. Problem A is an Algebra Standard 4.1 problem. It's on solving multi-step linear equations. Problem B is actually a grade 6 algebra function standard, 1.1, which is solving one-step linear equations. I know the decimals there might throw you off, or the students off, but it's really a one-step linear equation. Problem C is, again, a grade 6 algebra function standard 1.1, one-step equation. D is a 7th grade algebra function standard 4.1, which is solving two-step linear equations. And problem E is a multi-step linear equation from Algebra 1, Standard 4.1. So you guys are right on. Yeah, the thing that I predicted was going to be discrepancy was between the B and the C. Okay, because yeah, I wasn't. I myself thought which one was going to be easier, but obviously you guys agree more on these than I thought you would. So it's great, and I can tell that you guys are pros because then you know how these appear in a traditional math curriculum. So the purpose of this exercise is really to help teachers understand why the sequence of solving equations in our program, Introduction to Algebra, is different than traditional programs. Okay, so we'll see, and later on I'll ask you, after we go through the session, I'll ask you to rank again in a different way. Okay, so now I'm going to go back to the warm-up on this page, and you guys did a really good job. I think Pat did most of these, and whoever else did this, great job, and I had Connie check them. So just point out a couple of things that might be confusing. These were actually ordered for a particular reason, so here I have x plus 1, and the following problem was the opposite of x plus 1. So you could look at what you had right before it and see that you had a right side up cup. So the opposite of that would be an upside down cup. And if you had a red marker there before, now it becomes the opposite of the blue. Right? So that was the intent, that they were placed in this particular order for a reason. And then here we have the quantity x minus 1, okay? And this may be, one way to think about this is to say x plus a negative marker, okay? And that way you would know that you put a collection of x plus the negative marker, okay? Instead of thinking of it as x minus 1. And if you have this down, then you can see that there's a minus sign in front of the quantity, and you can think of the minus sign as, just like before, the opposite. So whatever we had, now we turn it back to the opposite. So if it was a right side up cup, now it becomes an upside down cup. If it was a blue, now it becomes a red marker. Okay? And then twice x plus 1, you just have to look at what was right above it and duplicate that amount. Right? And then 3 times the quantity, x minus 1. You can look and see what you have for x minus 1 and then just triple that amount. Okay. Here you have negative 3 times the quantity x minus 1. You can think of it as negative as the opposite. So what did you have right before it? you had the quantity, 3 times the quantity x minus 1. So the opposite of that was, turning off these cups upside down and then changing the color of the markers. Okay? And then here, this is something new for this lesson. I can't remember if it was week 11 or not, but I'll just talk about it anyhow. You have x plus a minus x. Okay? Just in the same way that you can represent a 0 pair using a positive marker and a negative marker, you can do the same thing with cups. You can show 0 pairs by putting an upside down cup, right side up cup, and an upside down cup. This also makes a 0 pair, and this becomes useful as we solve the equations later on. Okay. Any questions on this page before we move on? No questions? Okay. Let's move on to, let's see, slide number 8. Okay, right here. Okay, so here's the first equation from SB2. Okay, this problem is intended to illustrate the distributive property with cups and markers, which I believe that this is a review of week 11 because the students saw this in week 11. Okay, now how do we represent the 2 times the quantity x minus 3 using cups and markers? What I'd like to do is have Pat do the left side, okay, represent the left side of the equation on this, and Connie, would you represent the right side in this space right here, okay? And you can click and drag these little markers at the bottom to save yourself time, okay? And marks, after they build that equation using pictures, I'd like you to see where the finger is pointing. I'd like you to type the distributive equation in this space right here for me, would you? Okay. Now, as I said, while you're finishing that up, I just want to say that, because this is sort of a review of week 11, this particular problem, I want to focus our attention on how we might start solving this problem rather than actually solving it all the way through. Okay. One thing that we might do here, okay, if we look at, first of all, click on a happy face if you agree with the picture that's been built here. Okay, click on a happy face if you agree with Mark's equation right here. Okay, so we're so far so good. Okay, now look at this equation right here in the picture. What is one thing that you might do? What is one thing you might do to simplify this equation? And you can go ahead and type in the chat box. Okay, Jill says that we can add 6, so positive 6 to both sides. So, we can do, okay, Connie agrees. Okay, so I'm going to stick with that, okay? Okay, and I'm going to drag, oops. Okay, let's drag 6, oops, okay. Oh, thank you. Who's doing that? Okay, so hopefully we have enough. Do we have enough? No, we don't. Can we copy and paste them? Okay, we need, thank you, Joe. Oops. Okay, so here, let's look at the right side first. So on the right side, we added 6 positive units, okay? and also the same thing on the left side. Okay, what happens when we do that? Then what we can do now is that the blue markers and the red markers on the right side become 0 pairs. Okay, we make 0 pairs. And then here on the left side, we would have a collection of now 10 positive markers. So Mark, would you type the equation, okay, that we would have? So I'm going to put, yeah, I'm not going to, I was going to cross these out like that to show that we've made 0 pairs. Okay, so now we have 10, positive 10 equals 2x. Okay, so that is certainly one way we can do the problem. And then what we can do is proceed with fair share to find out how many markers go into each cup. Okay, so both Connie and Joe said that this is the way that they might do the problem, okay? Now let's take a look again at the same problem, okay? But, and I'm going to do this real quick. I'm going to copy, I'm going to try to do something to save myself time. Don't try this at home. So now same problem. Okay, same starting equation. I just copy and pasted our starting equation from the previous slide. Thank you, thank you. So now, tell me another way that we can start this problem. So right, the way that we did it was we added 6 red markers to each side. Okay, is there another way that we can do this problem? Yes, okay. Yes, I'm waiting for someone to say yes, and what would it be? What if instead of adding to what we have, what if I wanted to remove something from the math? Oh, okay, look above, sorry. Subtract -6 from both sides. Okay, is that your suggestion, Mark? Happy face if that's what you were suggesting? Okay, sorry, I didn't read it. Okay, so you can take away -6 from both sides, but how are we going to do that? Because we have to be able to subtract that same amount from both sides. I can see that I have -6 on the right side, but I don't have -6 on the left side. So how can I do that? Okay, so Mark says that we add 0 pairs to the left. How many 0 pairs do I need to add, Mark? So while he is answering that question, okay, as many as you want so you can take 6 negatives away. Okay, so I'm going to put 0 pairs. So that's 1 0 pair, 2 0 pairs, 3 0 pairs, 4 0 pairs. I'm not as quick as Joe. 5 0 pairs, and oops, just inconsistent. 6 0 pairs. Now, if you look at our, okay, have I changed the value of the starting equation by adding those 0 pairs? That is correct. No, I have not, because what I've added was basically a bunch of zeros, right? Okay, so now I can remove my my -6 from both sides. And thank you for Joe for doing that. So by crossing them out. Okay, so Mark, would you write the simplified equation that we have right now in this space right here? Okay. Maybe Mark is on the call. So, oh, okay, sorry. Okay, so we are showing, that's good, thank you for pointing that out, because we want our picture to match our equation. So thank you for doing that. So we are showing that we are subtracting -6 from both sides. And what I should have done is I should have retyped the distributed equation so we can see it better. But so yeah, so if you see, and I'm going to turn back to the previous slide just for a second so you can see. Okay, so you see how here we wind up with 10 equals 2x. Over here, on the different way that we started the problem, we also wind up with 10 equals 2x. So it really doesn't matter which starting point we take, just as long, it's really, a matter of preference. And I think sometimes we tend to have we are using teachers, but we know our teacher background to do things certain way. But I think that sometimes the students have the urge to want to remove things, so they might prefer that second method of of removing -6 from both sides. And if they're going to do that, then they have to add 0 pairs to the left side in order to be able to remove -6 from both sides. Click on the happy face if that makes sense to you. Okay, now where do you think this equation will fall and fit in a traditional equation solving sequence, like in a traditional math curriculum? Is this something you would put at the beginning or toward the end? Looks like a multi-step to me, right? Yeah, third section, whatever that third section is, and how many chapters you have on solving equations, right? Okay. All right, so let's move on, and I am aware that I have 8 minutes left. Let's do this one. Let's have Pat do the left side model, build the left side. Okay, Mark, this time you will build the right side of the equation. Okay. And while they're doing that, I just want to point out that this problem is intended to show how to represent -2x with cups. Okay, in the first lesson on solving equations, which was in week 11, students didn't have to deal with a -x term. So be sure that you think about how you want to represent it. Either with an upside down cup, a triangle, or with a minus symbol, or a black square, like I just pointed out, highlighted out for you in the special learner strategy. Right? Okay. So happy face if you agree that this is how you will model the equation. Okay, good. Now, what is one way that we can start this problem? Type it in the chat box. Okay, so Mark says that we can add 2 x's to both sides. Okay, I probably would not have abbreviated BS, but I understand what you mean. Yeah, so one way is to add 2 x's to both sides. So I'm going to just do that real quick right now. Okay, so I'm going to do that and that. Okay, so if I did what Mark said, I would wind up with 2 0 pairs with cups. See that? I'll put them right next to each other so you can see the 0 pairs like that. Okay, so then this would then become 0, and I would have, Joe, if you would type the simplified equation for me, it would be then 4 x's, and thank you for showing the step that the action that we took. Okay, 4x equals -4. Okay, how many people would have done it this way? Click on a happy face if that's how you would have done it. Okay, and it's okay if you don't click on it. Okay, all right. So let's do the same thing, or let's have the same starting equation. I'm going to remove this. Okay, and I'm going to put these guys back so we have the same starting equation. Okay, now Pat, you said that you would add 2 cups to both sides. Oh, I did too many. Okay. Okay. Add 2 positive cups to both sides. Oh, Joe said, actually Joe's the one who had a different way, was remove 2 negative x's. Now, if you wanted to do that, Joe, okay, if you wanted to remove 2 x's from both sides, what would you do? Because I have 2 negatives on the right side of the equation, but I do not have 2 minus x's, okay, on the left side. You're going to have to add 0 pairs of cups. Yes, and that's why I put that warm-up in at the beginning. And I said that we can do the same thing. We can create 0 pairs using cups, just like we did with the positive and negative markers. Okay, so once you add the 0 pairs using cups, now we can remove minus 2 x's from both sides. And what do we wind up with? What equation? Do we wind up with the same thing? Click on the happy face if you say yes. Do we wind up with 4x equals negative 4? Yeah, okay, so again, it doesn't really matter which way, and I would actually encourage you to try multiple ways of solving a problem with in the classroom with your students, because that helps them become more flexible and more fluent with solving equations. If they can see the problem and say, okay, I can do it either this way or that way, and if they have practice with both, they will become, I think, better at solving equations. Okay? Any questions on this one? And then we're not going to have the time to finish, but you can see here that at this point we'll do fair share to finish up our problem, and that each cup will get a negative 1. Okay? Moving on to the next page. Next equation, sorry. Okay, this one looks like it's really complicated in a traditional program, right? Because it has a distributed property and it has this minus sign in front of it. So, and we know how kids have trouble a lot of times with this distributed property. So, real quick, in the next 3 minutes that we have, Mark, would you model the left side, build the left side of the equation? Okay. Connie, would you do the right side of the equation? Okay. And again, while they're doing that, I'll just say that this problem is intended to show how to distribute a minus sign over quantity with more than one term. Okay. So one way to make it easier is you can think of the minus sign right here in front of the quantity as the opposite of. Okay, so one way, I don't know if this is what Connie's going to do, but one way to do this is that you can actually build what's inside the parentheses first and then take the opposite of the quantity. Okay, so I think Connie is already doing it straight, but if you have students that have difficulty, you can actually just first model x plus 4 blue markers, and then maybe draw an arrow to show that you're taking the opposite of the quantity. Thank you. Okay, but let me just real quick. Oh, okay, somebody's already moving that down. Probably move it further down and then put an arrow so we can show that. Oh, okay, that'll work. Yes. Okay, Pat, would you write for us the equation that we have after we've distributed the minus sign? You can do it in this space right here. Okay, and Mark has a lengthy chat box that I'll read off to everybody while Pat is writing the equation. Mark says that it's very important to understand that students do not always get the symbolic notation just because they saw pictures. You have to explain, you must have them explain how the pictures relate to the symbolic notation. And this does take time, okay? And agree, yeah, with Mark. yeah, students need a lot of practice. We are limited by the amount of time that we have in the session, which is actually already over. But yeah, it takes many rounds of practice and explaining, okay, how the picture relates to the symbolic notation for them to become better at it. Okay. All right. So that is our simplified equation after we've distributed. Okay. The next thing that I would have asked you is, how would you have solved this? So we're not going to do it, but I'll just have you type it in the chat box. I think one thing you can do is maybe remove a minus x from both sides. Okay. Okay. You can add a positive cup to both sides as well. Okay. So those are just two, and there's actually other starting points. If you want to start out with the red and blue markers, you can do that too. So those are just some of the things, and I encourage you to have model multiple ways with your students. I think sometimes spending time looking at one equation real good in multiple ways and generating discussion is probably more productive than having numerous equations for the students to practice. So just keep that in mind as you do these lessons with your students. Okay. And one last thing I'll do that I promise, I'm going to skip this one because it's the same, is I'm going to have you rank these now. Same equations in the order of difficulty, but now using as if you're using the cups and markers model. Okay, and type your answers in the chat box. Okay. And while you are deciding how you want to rank these, I would like to just tell you that if you want to read a more detailed explanation on the sequence of the equation solving lessons in our program, you can look at teaching tip number 2 on TP6, okay, of week 26, of course. It does have a nice explanation of why we do things differently in Introduction to Algebra. Okay, so let's take a look at how some of these were ranked. So Joe now thinks that D is easiest. So does Connie. Okay. And then I think Pat, you put some of these problems, ranked some of these problems twice. Did you mean to do that, Pat? Okay. Okay. And then Mark says that C and B do not fit in the model because C and B. Do you agree with that, everybody? Why doesn't B fit in the model? Because it has rational number coefficients. What about C? Yeah, you would have to start with a half a cup, and we don't have half a cup. Okay, and that's why. Okay, these would be difficult. So it's funny how the ones that we thought were easiest in the traditional program are actually the ones that were most difficult or not possible to do with a model. I take it that everybody ranked these differently than the first time around. Click on a happy face if you ranked them differently this time. Yeah? Okay. All right. Well, this is the end of the solving equation session. And I want to thank you for joining us this afternoon. Our next live session, which is also our final one for the school year, will be on February 23rd. Okay? And you'll be receiving an email reminder from Joe about that day's session. So thank you very much, and I'm going to stop recording now. Bye.